What's up, people? Welcome. I hope all of you guys are doing good, taking care of yourselves, and had a brilliant weekend. We're back into the hustle and bustle of the week. This is going to be the first session of physics this week, where we're going to talk about, we're going to solve some, the case study based questions, which is going to help you for your term 2 examinations. My name is Anoop, and this is Vedantu's 9th and English channel. I hope you've subscribed to the channel already. If you haven't done so yet, make sure you do that, and more importantly, hit the like button as well. Yeah, so that show some love, show some appreciation. That's all we ask for. Anyways, so a very warm welcome today, people. So what we're going to do in today's session is basically we're going to be doing a lot of subjective based questions. Basically, we're going to talk about the case study based questions. I've already released one video of this. Unfortunately, due to some reason, the video was only for 0.449 seconds. The whole video was not uploaded, which will be coming out today or tomorrow. But yeah, this is going to be the second part of the same video of subjective examination, the how to write your subjective exams case study based questions, part number 2. So without wasting any more time, people, let's get into the questions. So I have about 3 to 4 case study questions over here for you guys. You guys know the drill, people. So in a case study based question, you'll be given a paragraph that looks more or less like this, and then you'll be asked about 3 to 4 sub questions based on what the paragraph is given. So you have to read the paragraph thoroughly and try to answer those questions given. Now unfortunately here, since I can't write on the whole answer, we're gonna be going with objective format, where I'll be asking you questions and you have to choose option A, B, or C, or D. I'll give you about 5 to 10 seconds. Now if it's a numerical, then please do take all the time you need. Pause the video and try to answer it to the best of your knowledge, right? So without wasting much more time, people, here's the first question. If 2 or more resistances are connected in such a way that same potential differences get applied to each of them, then they are said to be connected in parallel. The current flows through these 2 resistors in parallel is, however, not the same. When we have 2 or more resistors joined in parallel to one another, then the same current gets additional paths to flow and the overall resistance decreases. The equivalent resistance is given by 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Let me just check if my video is fine. All right, yes. So yeah, people, how do you answer this question? It's this is a very simple paragraph. They're basically talking about parallel resistance over here. So this is the first question. So this is what they've given, the simple diagram. So you have R1, R2, R3 all connected parallelly, and I1, I2, I3 are the current flowing through it, and the potential difference applied to this circuit is V. They've not mentioned any values. So here's the first one. 3 resistances, 2 ohms, 6 ohms, and 8 ohms are connected in parallel. What would be their equivalent resistance? Options are less than 6 but more than 4 ohms, less than 8 but more than 6 ohms, less than 2 ohms, or more than 8 ohms. If you have 3 resistors, 2 ohms, 6 ohm, and 8 ohm connected parallelly, what would be their equivalent resistance? Now let's try to do the numerical part of it. All right, let's just try to solve this anyways. So we know that 1 by Rp equivalent resistance is equal to 1 by R1, which is 2, plus 1 by 6, which is R2, and divided by 1 by R3, which is nothing but 8. Now find the LCM over here. I believe 24 will be the LCM. 8 into 3, 6 into 4, and 2 into 12. So what are you left with? 12 plus 4 plus 3 whole divided by 24. So that's 16 plus 3, 19 by 24. That's basically 1 by Rp. So Rp is equal to 24 by 19 is what you get. So basically it's around 1 point something, right? 1 point something is what you're gonna get. So this is one way to do it. Basically do the entire mathematical, calculation of it, and then you can come to the conclusion that it is less than 2 ohms. But the best part about this question, guys, is that you don't have to do this. You really don't have to do the calculation part. Why? Because they are all connected in parallel. And one of the most important thing about parallel connection is that the equivalent resistance will always be less than the individual resistance. So here 2 ohm is the least resistance that you have. So directly you can come to the conclusion that it's definitely going to be less than 2 ohms, because according to the definition, if you just read the paragraph itself, the overall resistance is actually decreasing. It is going to be less than the individual resistance, which means that option C is the right answer, even without doing all this calculation. Even if you do the calculation, you'll get as 1 point something. But even if you don't do it, you can directly come to the conclusion that it's going to be less than 2 ohms. But since it's subjective, obviously obviously you will have to do the calculation and do the rest of it. So please pay attention, do the calculation part of it, and you'll get the answer. So the answer is going to be less than 2 ohms. Moving on to the next question, guys. Again, a simple question. A wire of resistance 12 ohms is cut into 3 equal pieces, and then it's twisted at their ends together. The equivalent resistance is what? Options are 2 by 8 ohms, 4 by 3 ohms, 3 by 4 ohms, or 5 by 6 ohms. Again, a simple question. Looks very difficult, looks very complicated for some reason, but it's actually not. So here is the fact, guys. You have a wire, right? The total length of the wire is whatever, and this wire has a resistance of 12 ohms. Now what I'm doing is that I'm just dividing this wire into 3 equal parts. So if I do that, what will be the resistance of each part? Then it'll be nothing but 12 by 3, because it's divided into 3 parts. The resistance of each part of it will be nothing but 4 ohms. So this is 4 ohms, this is 4 ohms, and this is also 4 ohms. Now they're telling that the ends are twisted, which means that they're all connected parallel to each other. That is what it means. They're basically connected parallel to each other because both the ends are twisted. Both the ends are twisted, which means that they're all parallel to each other. So find the equivalent resistance here. So 1 by R equivalent is equal to 1 by R1, which is nothing but 1 by 4, 1 by R2, which is nothing but 4 again, and 1 by R3, which is again 4. So it's nothing going to be 3 by 4, which is nothing but R equivalent. So R equivalent is equal to 4 by 3. For all those who went with option number C as the right answer, please remember, guys, it's 1 by R equivalent. Do not ever forget this. It's 1 by R equivalent. You should always reciprocate it once you get the value. So you'll get us 4 by 3 ohms and not 3 by 4. All right. Next question, people. Again, a bacha question. This one is also a very simple question. I am going a little fast because there's a lot of numericals involved, and we have to get through it within that 1 hour duration that we have. So if you need more time to solve the questions, once you read the question, please pause the video because it's a premiered video. So pause the video and then try to do it by yourself. All right. So here's the question. 3 resistors are connected as shown. The equivalent resistance between A and B is what? 3 resistors are connected as shown. What is the equivalent resistance between A and B? Is it 6 ohms? There are 3 resistors, 6 ohms, 3 ohms, and 1 ohm. What is the equivalent resistance between point A and point B? Very simple question. Now, just by looking at this, people, you can clearly see that they are all connected parallel to each other. They're not series. Even though they look like they're in series, they're not. They're actually parallel to each other. You can see that both the ends, all the 3 ends are connected to the same 2 points. All 3 ends are connected to the same 2 points, which means that they're all parallel to each other. So find the equivalent resistance. So 1 by R equivalent is equal to 1 by 6 plus 1 by 3 plus 1 by 1. 6 is the LCM, so into 2 into 6. That's going to be 1 plus 2 plus 6 whole divided by 6, which is nothing but what? 9 by 6. So R equivalent is equal to 6 by 9, which is nothing but what? 2 by 3 ohms. So that is going to be the answer. 2 by 3 ohms would be the right answer over here. I know I didn't read the question, but obviously the question was directly given over there, and the options were 2 by 3, 3 by 2, 4 by 3, and 3 by 4. So the answer is 2 by 3 ohms. Simple question again, isn't it? Very easy, very easy. Again, people, please practice as many simple numericals as you can so that your basics are strong, your foundation is strong. Once your foundation is strong, then you can easily answer the other questions that is there. All right, here's another one. Find out the current in each resistance given. There are 4 resistors given, each of 12 ohms, and you need to find out the current in each resistance. The voltage applied is nothing but 3 volts. What will be the current flowing through each resistor here? Options are 1 ampere, 2 amperes, 3 amperes, and 0.25 amperes. Now here is the thing, guys. If I have to see, all of them, are having or producing the same resistance, right? They all have the same resistance, and we know that current is equal to V by R. So if I take the first resistor, what is the voltage? Since they're all parallel to each other, the potential difference would also be 3 volt across all of them. It's going to be 3 volts itself, and the resistance is what? 12 ohms. So what is the current flowing through the first resistor? It's going to be what? 1 by 4. 4 3s are 12, which is nothing but 0.25 amperes. This is going to be for one resistor. All right. So individually, if you calculate for all of them, you'll still get it as 2.5 itself. So 0.25. This is also going to be 0.25 amperes because the potential difference is also the same. Voltage is also the same. Sorry, the voltage is the same, and also the resistance is also the same. So current will also be the same. So 0.25, 0.25, 0.25 amperes itself. So if you add them all up together, what will you get it as? 0.25 plus 0.25 plus 0. That will be basically 1 ampere. So the total current, if they ask, that will be 1 ampere. If they ask you for the current flowing through each resistor, that would be 0.25 amperes. All right, so 0.25 amperes would be the current flowing through each resistor individually. But if you talk about the total current flowing through it, the total current would be around 1 ampere. All right, so that is basically, if you talk about all of the resistors, like individually, what is the current flowing through all the resistors, and you add them up, the current flowing through would be, oh, I hope you guys were able to see it because of the image, maybe you were not, but yeah, this is what I was talking about. People, 0.25 plus 0.25, 0.25 plus 0.25, because individually all of them have the same amount of current flowing through it, and hence the answer would be 0.25 amperes. Unfortunately, here they've chosen it as 1 ampere for some reason. Again, they've gone with the same logic that the question is very ambiguous in the sense they've not clearly mentioned over here. So I am going to go with 0.25 amperes over here because they're talking about each resistance. So each resistor, the current flowing through them would be 0.25 amperes. All right, that's pretty much it. If you want to find the total current, again, the total current would be completely different. You have to find the equivalent resistance here, then divide that, divide 3 volts by the equivalent resistance. So you'll get the necessary answer. So it'll be 4 by 12, which is nothing but so it'll be 1 ampere itself. So 1 ampere itself, because the equivalent resistance here would be what? 1 by 12 plus 1 by 12 plus 1 by 12 plus 1 by 12, which is equal to what? 4 by 12. So it'll be 12 by 4. 4 3s are 12. So if you talk about the total current, total voltage by total resistance, that is nothing but 3 by 3. Again, you'll get it as 1 ampere itself. So the total current is 1 ampere. But if you talk about the individual resistance, again, 0.25 amperes. I know I took a lot of time to explain it, but I hope that you clearly understand why they've written it as 1 ampere over here. The question is very ambiguous. So I'm going to go with the 0.25 amperes as the right answer over here. All right. Okay. Next question, guys. Case number 2. Again, we're going to get it on the next case study based question. Here is one. Several resistors may be combined to form a network. The combination should have two endpoints connected to it, connected it with a battery or another circuit element. When the resistors are connected in series, the current is in each resistance is same, but the potential difference is different in each resistor. When the resistors are connected in parallel, the voltage drop across each resistance is same, but the current is different in each resistor. You've already studied the basic concepts, people. In series connection, the current remains same, but the voltage is different across the resistors. But in parallel connection, the voltage is same, whereas the current across each resistor is going to be different. So based on that, here is the first question. The household circuits are connected in what? Series, parallel, both series and parallel, or none of the above. At home, what is the form of connection that we go with, or what we prefer? Is it series or parallel? Very simple question. I'll answer the question in 5 seconds, people. Take your time. Pause the video and take all the time you want, but give the right answer. Select the right option. I'll give the answer in 3, 2, 1. It's going to be parallel, people. Because at home, the reason is why? Because there are 2 reasons. One is the potential difference would be same, so it will not affect the functionality of the device. Secondly, even if one device gets short circuited for some reason, the others would continue to work. But in parallel connection, even if one gets disconnected or one is short circuited, the rest of it would not work at all. But here, that is not the case. The others would continue to work. For 2 reasons, we connect them all in parallel. All right. Next question. The 2 wires of each resistances are initially connected in series and then in parallel. In the graph, it shows the resistance in series and in parallel. Which of the following is correct? Now, please remember, guys, here it's a voltage versus a time graph, but on the x-axis you have voltage and the y-axis you have current. All right, and they have 2 connections. So same 2 resistors, initially they were connected in series, then they were connected in parallel, and they came to this conclusion. This is the graph they got. Now the question is, which of the following options are correct? Options are: A denotes parallel combination, B denotes series combination, A denotes series combination, and B denotes parallel combination, or none of the above. Now pay attention, guys, pay attention over here. See, one thing that we know is that in series connection, in both the cases, when you talk about series and parallel, the thing about series connection is that because the resistance is higher, because in series connection, the individual resistance gets added up. So the current generally is going to be higher. As you increase the voltage, the current is not going to be that high. And in parallel connection, because you're reducing the voltage, reducing the resistance, the current flowing through would be much more higher. Why? Because in parallel combination, the equivalent resistance is going to be less than the individual resistance. So resistance is comparatively lesser, and we know that current is inversely inversely proportional to resistance, which means that more is the resistance, lesser is going to be the current, lesser is the resistance, more is the current. And in series connection, the resistance is more. This is what is happening in series. In parallel connection, the resistance is going to be comparatively lesser, which means that the current flowing through it would be much more higher. That is what happens. So here, if you look at it, B is much more higher. You can see that the current value in B is much more higher than in A. So that means that A is in series and B is in parallel. So you can come to the conclusion that A denotes series and B denotes parallel. So option C is the right answer over here. All right. Now, if it was the other way around, people, if it was voltage versus current graph like this, then it would have been different. Then you could have said that if this is B and this is A, then you can say that A is, A is in series. A is in series and B is in parallel. But A is in parallel and B is in series, because you see that over here it's completely different. Because you can see that as you increase the voltage, the current flowing through B is actually lesser and A is much more higher. So you can say that A is in parallel and B is in series. But since it's current versus voltage graph, the slight change would give you a different answer. So for all those who are wondering, that is the reason why you're getting option C is the right answer. So A is in series and B is in parallel. All right, too much explanation. All right, here's another one. The equivalent resistance of R1 and R2 when connected in series is R1. And when they're connected in parallel is R2. Then what is the ratio? Okay, so here's the question, guys. Okay, so let's take it as R1 first. What is R1? The series connection. Series connection is nothing but R1. So it's nothing but R1 plus R2. Parallel connection is what? 1 by R2, which is equal to what? It's going to be 1 by R1, small r plus 1 by R2, which can be written as what? R1 plus R2 divided by R1 into R2. This is 1 by R2. So what is R2 equal to? R1 into R2 divided by R1 plus R2. That's what you get, right? Now you're supposed to find out the ratio. So if I take R1 by R2 as the ratio, then it's R1 plus R2 whole divided by R1 into R2 whole divided by R1 into R1 plus R2, right? R1 plus R2. This will go to the numerator. So what will you get? R1 plus R2 into R1 plus R2 divided by R1 into R2. My God. So you'll get it as what? R1 plus R2 the whole square divided by R1 plus R2. R1 into R2. So the answer to this question would be option number C, guys. Lot of calculation, but yeah, I mean, the answer would be option number C because it makes absolute sense. Mathematically, I think it makes sense to you people also. You're supposed to find the ratio over here. So R1 is the equivalent resistance of series and R2 is the equivalent resistance of parallel. And when you put them all together in the form of a ratio, this is what you get. So answer would be option number C, if I'm not wrong. So that is the answer, guys. Moving on to the next question, people. Here is another one. Again, this whole session is going to be about resistance today. So here's another one. A good practice for you guys because there's 100% going to be questions from resistors and series and parallel connection. So the more you know, the more you practice, the better it gets. Here's another one. The equivalent resistance between point A and point B is what? Here, there are 2 points A and B given. What is the equivalent resistance between point A and point B? 3 ohm, 3 ohm and 6 ohms are the 3 resistors given over here. First thing is, the first common thing that I'm pretty sure every one of you guys have already figured out is R1 and R2 are in series. So find that out. So R equivalent or R12, you can take it as R12 is equal to R1 plus R2, which is equal to 3 plus 3, which is nothing but 6 ohms. Now that you've solved this, you know that this is your new resistor. This is your new connection right now. This is what it looks like. This is 6 ohms. This is also 6 ohms. So they're both parallel to each other. Find out the equivalent resistance. So 1 by RP, which is R equivalent, is equal to 1 by 6 plus 1 by 6, which is equal to what? 2 by 6. So R equivalent equal to 6 by 2, which is nothing but 3 ohms. So the answer is going to be 3 ohms. That's it. All right. I hope you got people. I mean, see, I'm going a little fast. I know that. But again, like I told you, it's a premiered video. So pause the video, put it on in the chat box. What do you think is the right answer? Put it on in the chat box. And more importantly, put it on in the comment section also. So far, out of 8 or 9 questions that we did, how many questions did you guys give the right answer for? All right. Let me know that also in the chat box right now. Here's another one. The last case study based question for case 2, then we'll go on to case number 3 as well. 2 resistances 10 ohms 3 ohms are connected in parallel across a battery. If the current is 0.2 amperes in 10 ohms, what is the voltage supplied by a resistor by the battery is? Okay, so here is the connection. Here I'll just draw the connection first, people. So these are the 2 resistors connected parallel to each other. This is 10 ohms. This is 3 ohms. 10 ohms and 3 ohms. All right. Okay. Okay. So current flowing through 10 ohm resistor is given as 0.2 amperes. This is given as 0.2 amperes. You need to find out what is the potential difference of the battery. Now, here's the thing, guys. They're both connected in parallel, which means that the potential difference across 10 ohm resistor would be the same as the potential difference across 3 ohm resistor, and that will be basically the same potential difference as the battery. Absolutely, right? Because we know that in parallel connection, the voltage, the potential drop, the potential difference would exactly be the same, which means that what is the potential difference? Potential difference would be across, okay, let's talk about the potential difference across the first resistor R1. All right, we'll take it as R1, this is R2. So R1 is equal to what? V into I1 into R1. So I1 is 0.2 amperes and R1 is 10. So what is the current flowing through? The potential difference is nothing but 2 volts. So if that is 2 volt, this will also be 2 volts itself, because they're both connected to parallel, they're both connected parallelly, and the potential difference applied to the battery will also be 2 volts itself. Why? Because they are all connected in parallel. So the answer for this question would be option number E. Logic. They're all logical, guys. It's simply logical. So directly you can say that the answer is 2 volts. That is the answer. All right, moving on, guys. Moving on to the next question. Unfortunately, okay, here they have, okay, these are all different answers, unfortunately, but yeah, this is the answer, guys. The answer for fifth question is 0.2 into 10, which is nothing but 2 volts. I think they have given the answer for all the other questions also. Is that so? All right. Anyways, moving on, guys. Moving on to the next case study based question. But before we get into that, one important and amazing news for you people. We have started with the Drona batch, the last set of revision for you guys to enroll into, where you get to study with the best of the best teachers, you know, like the last sprint of term 2 examination with Abhishek sir, Harsh sir, Ankara ma'am, Amit sir, Amrit sir, and Anubha ma'am as well. So these are the amazing set of teachers who will be teaching you in the Drona batch. So you know the level of the level of excellence is going to be super duper high in this particular batch. This is going to be for 10 standard students. We have something for 9 standard students also. I'll tell you how to enroll into it. For 9 standard students, we have Udan for class 9. This is going to be taken up by our very own teachers at Vedantu, 9th and 10th English channel. We have Gopal sir, and we have our, why am I not able to recollect the names? I'm so sorry, but yes, all the amazing teachers. Guys, I have a very bad memory when it comes to names, alright? I'm really sorry. But yeah, Gopal sir and Bhavna ma'am and Maria ma'am and all the amazing teachers. I'm not able to recollect the name for some reason. I am so sorry. But nonetheless, this is going to be starting on 21st of Feb. That is basically today is the start day for this. But it's not too late yet. And if you're planning to prepare for your 9th standard syllabus, this is an opportunity for you guys with over 30 plus live sessions for all the subjects that we just talked about, taken up by all your favorite master teachers on YouTube. And it'll be including some tips and tricks, last minute revision with doubt solving, and you also get to study in English, so both Hindi and English as well, because I know that a lot of you guys are more comfortable in English than with English alone, like how I do it. And yes, this is going to be for about 720 rupees, so it's a very, very affordable price. Let me just quickly tell you or show you how to enroll into those classes as well. Now, this is subjective part 2. I'm really embarrassed that I couldn't couldn't come out of the names for some reason. I was like completely blank when it came to the names. I don't know what happened there, but nonetheless, please ignore that, people. Okay. So anyways, so we have here over here. This is the part 1 of subjective case study based question. So if I go to CBSE Term 2 full syllabus over here, click on the link and it'll directly take you over here. This is directly going to be enrolling you into the Drona batch, where you get to study with all the amazing teachers over there. So you can study, prepare, and get more confidence, or gain as much confidence as you possibly can, since your exams are approaching really fast. So the entire course, people, for the next 3 months, that is until the end exam is done, there's only Feb, March, April, until the end of April, that is until your examinations are done, these classes would be going on, and all of this you're getting for just 2,970 rupees, which is a very, very affordable price, which means about 1,000 rupees per month, close to 1,000 rupees per month. And on top of that, if you that is if you use my coupon code AME Pro. Without the coupon code, it is going to be a lot more higher. If you just remove the coupon code for a second, the price is actually 3,300 rupees. But after you apply my coupon code AME Pro, unfortunately my keyboard is not working. Yeah. yes, I know. So it's AME Pro, people. So AME Pro. If you use my coupon code AME Pro, you can see that the price drops down to 2,950 rupees. And on top of it, you also have a lot of other offers. Also, you have Amazon cashback of 15% as well, and MobiKwik of 10%. So if you guys use any of these apps, which I'm pretty sure you do, you get another 15% over there as well. So about 25% if you use Amazon cashback, and if you use MobiKwik, that's about 20% cashback right there. Now, if you go with the Classic, I prefer that you would go with Classic because it's the same cost, and more importantly, under Classic program, you'll also be getting the Doubts app as well. So you can actually download the Doubts app outside the session, and you can get that doubts sorted over there as well. So that is one opportunity for you guys. Again, you get to study with the best of the best teachers, so there's no compromise in the quality of education that you get. Now, if you go for CBSE 9th also, it's pretty much the same. So 9th standard is going to be again, it's CBSE 9th crash course. So here the price is actually, for some reason, it's showing a lot higher. One sec, guys, let me just check for the Udan batch over here, grade 9. Okay, yes, Udan revision batch. You have to select on Udan revision batch. That's 720 people, 720 rupees for the rest of the month, for next 30 sessions. That is for 30 sessions. That's 720 rupees is a very, very affordable price, and more importantly, it's going to give you the last minute push that you require to ace your exams. So good luck. Peace out. Okay, so that is about the sessions. That is about the opportunities that you have to start with your preparations right away for both 9th and 10th standard. 10th standard makes, you guys know that your time is very, very important. So utilize it really well and make the best of it. All right, guys, the last question for today, the last case study based question, case number 3. Here we go. This is about heating effect of electric current. So I'm going to read the paragraph. You can pause the video and read it if you feel like I'm going a little fast, and then solve it accordingly. The heating effect of electric current is obtained by transformation of electric energy in heat energy. Just as mechanical energy used to overcome friction and is converted into heat, in the same way, electrical energy is converted into heat energy when an electrical current flows through a resistance wire. The heat produced in a conductor when a current flows through it is found to be directly dependent on the strength of the current, the resistance of the conductor, time for which the current flows through the conductor. So mathematically, the expression is H is equal to I square RT. It's not I into 2 into RT. It's I square RT. The electrical fuse, electrical heater, electrical iron, electrical geyser, all of these are examples of heating effect of electric current. So let's see, guys, what do you think would be the questions based on it? So here's the first one. What are the properties of heating element? So if you have a heating element, what is the most important property that you need or that you think is required to be chosen for it to be chosen as heating as a heating element? Options are high resistance and high melting point, low resistance and high melting point, low resistance and high melting point, or low resistance and low melting point. I would say, guys, okay, option C, B and C is basically the same thing. Let's make this also as, okay, so high, low, high, low. Let's make it as high, low for some reason. Okay, let's just go with high and low. All right. So anyways, guys, what do you think is the right answer for this question? Please put it down in the chat box. Let me check it out. I know you know the answer, people. The answer is going to be 3, 2, 1. It's going to be high resistance and high melting point. You need high resistance because we know that heat energy produces directly proportional to I square RT. So I square RT. So more the resistance, more the heat energy. So the higher the resistance, the more the heat energy produced. And you also need a high melting point because if you have a low melting point, the wire will just melt and it will not lead to anything good. So option A is definitely the right answer. Second one, what are the properties of an electric fuse? When you talk about an electric fuse, what is that most important property that you have to go with? Low resistance and low melting point, high resistance and high melting point, high resistance and low melting point, or low resistance and high melting point. If you talk about an electric fuse, people, the thing is that you need, you can say that you definitely need a low melting point because you want it to melt and disconnect because it's a safety circuit. It's a safety device which is basically there to disconnect the current flowing through it if the current becomes too much. So the only thing that makes sense over here is to have high resistance but low melting point. So option C is the one thing that makes sense over here, because again, you need high resistance but you need low melting point because it's a safety device. No, you need the wire to get disconnected when the current becomes a little too much. So that is the right answer. Third question, guys. When the current is doubled in a heating device, the time is halved. The heat energy produced is what? Doubled, halved, 4 times, or 1/4 times. If the current is doubled and the time for it is flowing through the time for which the current is flowing through it is halved, what happens to the heat energy? Very simple question. Again, pause, try to figure it out yourself. The answer, guys, is nothing but what? It's nothing but H is equal to I square RT. That is the formula. Current is doubled, so it's 2 into I square, and time is basically halved, so it will be 1/2t. So what is this? 4I square R into 1/2t. So what will you get? It will be basically 2 times the original heat energy. Whatever is the original heat energy, which is nothing but I square. So this I square RT can be written as H. So the new heat energy, which I'll take it as H dash, is basically twice the original heat. So it's going to be double of that. So the answer is going to be option number A. Next one, people. Here's another one. A fuse wire melts at 5 amperes. If it is desired that the fuse wire of the same material melts at 10 amperes. The new radius of the wire is 4 times, 2 times, half times, or 1/4 times. So here is the thing, guys. The initial current is given as 2 amperes. The new current that you want to get is 10 amperes. So we know that, we know that current is inversely proportional to resistance. More is the resistance, lesser is the current. You want the current to be high, which means the resistance has to be low, because you want to increase it to twice the original current. So this is 5 amperes. No, it's basically twice of the original current, which means that your resistance has to be much more lesser. It has to be 2 times lesser. If your current has to increase 2 times, then your resistance has to become 2 times lesser. Now, we also know that resistance is equal to rho into L by A, which means that resistance is inversely proportional to area. So if you talk about the radius, what is area equal to? Area is equal to pi square r. So right, it's something called pi r square. Pi r square. Area is nothing but pi r square, right? So that means that if you increase your radius two times, your resistance will decrease by 2 times. If your resistance decreases by 2 times, your current will also increase by 2 times. So the answer would be 2 times. All right, long calculation, but it's actually quite simple. I'll just repeat it one more time, people. We know that current is inversely proportional to resistance, and we know that resistance is inversely proportional to area, right? So if you increase the area, resistance will decrease. So if your resistance is increasing, if your area is increasing by 2 times, resistance will decrease by 2 times, right? Because it's inversely proportional to each other. That means that your radius has to increase 2 times. If your radius is increasing 2 times, area will increase 2 times, which means that the resistance will decrease by 2 times. If your resistance decreases by 2 times, then current flowing through it would increase by 2 times. So the answer would be option number B. Yes, the answer would be 2 times. So that is the answer, guys. Here's another one. The last question for today, people. That's it. I'm not going to fry your brains anymore. Here's one. When a current of 0.5 amperes passes through a conductor for 5 minutes and the resistance of the conductor is 10 ohms, what is the amount of heat produced? Options are 250 joules, 5000 joules, 750 joules, or 1000 joules. Again, use the same formula, people. Same Joules law of heating. H is equal to I square RT is the same formula that you have to go with. So it's 0.5 square into resistance is 10 ohms into 5 minutes. Now convert that to seconds, because you have to calculate in terms of joules. So into 60, because you have to convert to joules, you have to convert it to seconds. So convert that, multiply with 60. So what will you get? You will get it as what? 0.25 into 0.5 is 0.25 into 10 into 5 6 is 30. So that's 300. So this is nothing but what? 1/4 into 3000, because 0.25 is nothing but 1/4. So 1/4 into 3000, which is equal to what? 750 joules. So the answer would be option number C. That's it. All right. Well, people, that is the final answer for this question. So we have done 14 questions, if I'm not wrong, 14 questions or 15 questions so far. So let me know in the chat box, people, how many of you guys got 14 out of 14 all correct. Again, be honest to yourself. Put on the chat box and the comment section as well. Let me see how many of you guys are geniuses and geniuses, so that we get an idea of how well you're prepared for your examination. So 14 questions, people. Let me know how many of you guys got it right. So that's pretty much it for today's session. Thank you for joining. And again, Udan and your Drona batch has already started, or is going to start from this week onwards. So this is the opportunity. This is the last chance for you to boost your scores to get to where you want to. So don't waste this. right? Grab hold of this so you don't regret it later, because ultimately, people, if you don't use the time that you have right now, you will definitely regret it. And I don't want any of you guys to have that feeling, because you guys know how feeling of regret is. So don't let that come back and haunt you later. All right, so good luck. If you enjoy the video, thumbs up, subscribe to the channel. I'll catch you guys in the next session. Take care of yourself, stay safe, have a great day ahead. I'll see you soon. Enjoy yourself. Bye bye, people. Adios for now. Take care. Peace. Bye bye. Take care.